Now let's define the simulation conditions for deformation. In this training, I will deal with two cases. The first one is to define the displacement of the target type. Displacement in target type means that if there is only one node that satisfies the displacement condition, the simulation ends. So in this example, I will input 1 micrometers for the x-axis. I already mentioned that the initial pressure condition needs to be set even though the target type is defined. Therefore, let's click this plus button and I will apply a pressure of 10 megapascal in the x-axis of plus YG plane. And the next one is boundary conditions. Please click this plus button. In this case, I will choose fixed or minus YG plane. So now we have entered all the conditions. With original structure is to set whether to output an original structure file before deformation. So if you want to create an original file, please check this button. In this case, I will check it. And then please click this Save button. Let's start the simulation. When the calculation is complete, this message appears. The result files exist in the folder where the project file is saved. Let's look at the created files and folders. Since I selected with original structure, the file name with origin are the result files before deformation. There are some text files that contain area and volume information for each layer, and a str file which includes 2D mask information. Now let's look at the files saved in each folder. In the output folder, there are in files. Mesh and layer information is included, and simulation conditions for deformation are saved in this file. In the mesh folder, there are various str files. They are the results during creating a mesh file. So you don't need to check all the str files normally, except for the case when there are some problems about mesh generation. Next, let's click on the result folder. There are DAT file and mesh file. They are 3D structure files after deformation, but I recommend to use a DAT file for analyzing the results. To check the result files, you can use TX Viewer program. Please double-click it. The first one that we check is a str file. To load the result file, click File and Open, or click this Open icon, or just drag and drop the file. str file includes 2D mask information. So let's click this mask structure. You can identify layer name, thickness, color of each mask structure, and turn on and off the mask. The next one is a 3D structure file. To check the structure changes before and after deformation, let's load the origin mesh and DAT file. When you want to compare two files like now, click the file name, right-click, and select New Horizontal Tab Group or New Vertical Tab Group. In the toolbar, there are a lot of options. Most of all, by using those viewer options, they can be very useful for checking the structure of the direction that you want to see. Also, I will briefly explain how to use the shortcut keys to check the structure result that can be used the most. If you click the left mouse button, you can move or rotate the structure. And if you hold down Ctrl key and move the mouse wheel, the structure will be zoomed in or out. And if you hold down Shift key and move the mouse wheel, you can move left or right. Moreover, while holding the Ctrl key and alphabet X key, and then move the mouse wheel, the structure will zoom in or out along the x-axis. In the same way, while holding the Ctrl key and alphabet Y or Z key, and then move the mouse wheel, the structure will zoom in or out along the Y and Z axis. If you want to compare the structure files for the same viewpoint, right-click and click Copy View. Then, if you click Paste View, you can compare the result files from the same viewpoint. First of all, this result was an example in which the displacement of the target type was set to 1 micrometer. Looking at the result of the x-coordinate in the data, you can see that the displacement of the x-coordinate has changed by 1 micrometer, from 5 to 6. By the way, only few layers are visible right now. To check the layer information and set the on and off state options, please click Turn on and off. Information such as layer name, nodes and elements, color of each layer is displayed. If you click here, it is turned on and off for the entire layers. And you can easily change the on and off state for a specific layer. By clicking on the bottom layer step by step, you can check the structure. Let's apply control float to all layers. You can select the result data that you want to check in value type. electric field, current density, displacement, and stress and strain results can be checked. The results checked in TDeformX Creator, Option, and Output data are displayed. If you check it, a legend is showed up. Click Tools and Options. There is a Legend tab. You can control the legend settings. In this case, I will check this, show the legend title. If Auto Linear is selected in Update, a legend is displayed by automatically linear interpolation from the minimum to the maximum value. And if Auto Log is selected, a legend setting is changed as a log format. In addition, the user can adjust the legend range by yourself. Please click this Set Legend button. I will tell you how to modify the legend setting. At first, please click this Delete All button. Just as an example, based on the minimum and maximum data, let's change the range from 0 to 0.8 at intervals of 0.05. And please click this OK button. You can see that the legend is modified. And then let's check the results. The average and node function displays the result of arithmetic average of element data adjacent to each node. In case of displacement results such as UX, UY, and UZ, there is no difference in results according to the function because these results are calculated by the method of outputting calculation results for each node. Also, there is a function to check in grayscale form or check it more smoothly like this. Other than that, there are many view control options, so you can change the settings to suit your preference. Here is the data information. You can check the maximum, minimum data and location information for the result. There are two ways to use it. By selecting a specific XYZ position or by defining the specific area. Find the information in the selected zones is to check the results only for layers that have control flood turned on. So click zone on and off, and I will turn on the layer G only. And then select value type like this. After that, click this Update button. You can see the max and min data and location information. Update the data info automatically when the legend value type is changed is to change the result according to the currently selected value type. Back here, And then if I change the value type, the information is also changed. Also, you can check the results for a specific area set through value blank. Click this value blank. After selecting the X and Y axis and adjusting the slide bar to define the area, click Apply. And then you can check the min, max, and location information for the user-defined area as follows. And there is a cross-section. I will talk about it later on. Therefore, I have explained the most used functions of TX-Viewer, and through this, you will be able to analyze the results. Let's define another example. At first, let's load the project file for the example 1. And I will change the project file name. And I will delete the simulation conditions. In this case, I will fix minus YZ and plus YZ planes and apply the pressure here. Therefore, only pressure will be applied, so set activation to no in target type. And then please click this plus button. Check surface and double click this surface. And then I will apply the pressure for the Z direction. Therefore, let's enter 500 for the Z direction. And for the boundary conditions, please click the plus button and I will select fixed. And then I will fix minus YZ and plus YZ planes. Like this. In this case, I will uncheck with original structure. And then please save this project file. After that, click Run. The simulation is finished. Let's check the result. This time, I will check only the DAT file. You can verify that the structure has been created as follows. I will talk about cross-section, which is very useful. You can extract and analyze the cross-sectional data. By adjusting the slide bar, you can extract a specific area. Click Extract. Cross-section file will be opened automatically, and if you click right mouse button, there are a lot of menus. Most of all, when you select distance, you can measure the distance. Please use various functions mentioned in example 1 to analyze in the same way.